Assalamualaikum doctor. We are from group 12 and today we are going to present about flash separation, ethane and propane. Our group member consists of Eng Cheng Yuan, me, Azai Kambi Fidaus, Nurul Alia Nabilah binti Azni and Rohaida Idayu. This is an overview of our project presentation. Moving on into the introduction, flash separation is a simple and commonly used process to separate a hot liquid mixture into two parts, vapor and liquid. This happens when high pressure mixture is introduced into flash drum at lower pressure. This method is widely used in industry like oil refining and natural gas processes because it is quick, energy efficient, and doesn't require complex equipment. Example of flash separation is a mixture of ethane and propane. In this case, the more volatile component quickly turns into vapor, while the less volatile ones stay mostly in liquid form. As a result, the vapor phase becomes richer in the lighter component, and the liquid phase contains more of the heavier one. This type of separation is useful when it is important to collect each phase with a different composition, especially in processes where different components are needed for different product or further treatment. Next is project objective. The objective of flash separation is to efficiently divide the multi-component mixture into vapor and liquid phases based on their volatility. This objective can be broken down into specific goals. The first one is to improve energy efficiency. Flash separation use less energy compared to other methods like full distillation, making it more cost effective. Secondly, is to maximize recovery of both phases. The goals is to collect as much as possible of each component in the desired phases, reducing the waste of loss. Thirdly is to obtain stream with different composition. After the separation, the vapor and liquid contains varying proportion of the original mixture, making them useful for different steps in production. And lastly is to support safety and the environmental compliance. The goal is to operate under controlled condition, ensuring the process meet environmental and safety regulation.
For this project, the feed composition used was 80% ethane and 20% propane by mole. This ratio is chosen because it reflects a typical natural gas stream where ethane is usually more abundant. It also allows us to study the separation behavior between a lighter and a heavier component using realistic conditions. Next, the pressure was set at 500 kilopascals. This is considered as a moderate pressure which is suitable for partial vaporization. At this level, the mixture is able to separate effectively into vapor and liquid phases without the need of extreme pressure adjustment. The temperature used was 233.15 Kelvin, which is around minus 40 degrees Celsius. This low temperature is important to cool the mixture down enough so the propane condenses into liquid, while ethane, which is being more volatile, stays mostly in the vapor phase.
The saturation pressure of ethane and propane is calculated using the Anton equation. The value of A, B, and C is taken from the Anton equation table. The ethane Anton equation parameter, A is 6.80267, B is 656.4028, the temperature is negative 40 degrees Celsius, and C is 255.99. For, for propane, A is 6.82970, B is 813.2008, and C is 247.99. The temperature T must be transformed from Kelvin to degrees Celsius first to complete the calculation. The saturation pressure of ethane is 5802.6644 and the saturation pressure of propane is 831.5585. To calculate the bubble point pressure, we have to firstly assume that the composition of X and Y is equal to the initial composition, which is Z1 equals to 0.8 and Z2 equals to 0.2. The bubble point pressure is calculated using equation from the Introduction of Chemical Engineering 8th edition. Equation is 13.20. And the bubble point pressure is 641.0403. Next, we will calculate the dew point pressure. We also get the equation from the same book, however, it is equation 13.21. So we will get the dew point pressure is 352.3325. The pressure of the system is 500 kPa, which is between dew point pressure and bubble point pressure. Thus, the system is in two-phase region and flash separation can be occur.
For the flash calculation part, we started by converting the P saturation from millimeter of mercury to kilopascal. The available system pressure is 500 kilopascal. Then we will substitute all the values into K equals to P saturation over P, and we will obtain K1 equals to 1.5473 and K2 0.2217. The feed composition is given as Z1 0.8 and Z2 0.2. We then apply the Raychard-Rice equation to determine the vapor fraction V using trial and error. After several trials, we got V equals to 0.662. Then we calculate the liquid fraction, which is L equal to 1 minus V, and we will get 0.338. For liquid composition, we will use formula X equals to Y over K, and we will get X1 equals to 0.5872 and X2 0.4127. In this project, we apply flash separation into a binary mixture of ethane and propane under defined conditions. And using thermodynamic principles, we calculated key parameters such as dew, saturation, and bubble pressure, and also performed flash calculation to determine the phase composition. At 500 kilopascals and 233.15 Kelvin, partial vaporization occurred. This resulted in two distinct phases, which is liquid and vapor, with ethane concentrated in the vapor phase due to its high volatility, and while propane remained mostly in the liquid phase. So this confirms the main goal of a flash separation, which is to separate components based on volatility differences. That's all from our team. Thank you.